Okay, now let's talk about question 12. So question 12 is a typical uh, biological problems that how we're going to solve the thing. So as I say, you go to buy the 10-year series, okay, and with the answer key, right, then there's a better. But now let's look at this thing. They say that the scientists, okay, I put sirs are actually scientists, are interested in the populations of a particular species. They attempt to model the population's P at time t days after using differential equation. This is what we are doing normally when we do environmental study or ecological study, that we try to form a population's dynamics. So if you are interested actually in the wastewater treatment plant, we also form some dynamic modeling, okay, with different species of microorganisms. They have different kinetics. I think your chemistry will learn kinetics, right? In biological, actually biochemical engineering is actually we have a lot of kinetics there. So normally the inhibitions, competition, that kind of stuff. So it definitely can be generalized with some equation here. What we use in the like wastewater treatment, we use mono equations that for municipal wastewater, and for the industrial wastewater we use other type of correlations. So at here they say that the P is using differential equation, so there's a differential equation problem. Initially the population observed to be 50, so P naught is equal to 50. This is given. So whenever you solve an engineering problem, you put a given here. But I don't really like the way that engineer do the problem. Somehow it's very objective, but you lost some fun here. So when you do mathematics, remind yourself that it's supposed to be fun. It's not very boring subjects. Okay, initially the population observed to be 50, and after 10 days, the population to be 100. So you have two conditions here, we call initial condition and one specific equation conditions. So they say the first model that scientists use assumes the rate of change of the population, that means dp dt is a rate of change. Rate that means dt of the population is proportional to the population. So this is the first order equation, we call it. In your chemistry, you know that the first order kinetics is a force over population. So this is the initial guess. But write down a differential equation for this model and solve it for P in terms of T. So then ask us to solve the things with 5 marks. Okay, since I've written down the correlation, then this is very simple that we can solve that. So dp dt equals to kp. However, is the population dropping or increasing? We have to ask ourselves. So this is population is a species. So normally, when you have more populated, it will grow. Am I right? But if you learn biochemistry, you know that very well that it might not be the case. Normally, when you grow too much, it will die as well. So to a certain extent that it might have some decaying factor, but nevertheless, okay, in this question it's not going to tell you about chemistry or biological science. So the dp dt equals to kp. So then how do we go to solve this differential equation? You learn from chemistry as well in your physics. I think there are certain things that you learn. So you go and remove your kp to the same variable here, dp and p here. So this is your t, nothing in the p. So you find the k, right? K is a constant, so what you can do is that leave it out. So you got p over p naught. So whenever you integrate 1 over p dp, it become ln p. So this is p over p naught. Okay, final minus initial, because it is a logarithm, so we can make a division. Okay, then t equals to t naught. T naught itself is 0. Okay, but you also know that 1 over k ln p over p naught is equals to t. So now we know that t naught is 50. 50 don't know what I mean, there's no, but when t equals to 10, okay, your p is equals to 100. So you can find your k very easily by doing substitution. Okay, ln 2 divided by 10. So this we later we will look at the thing is called half-life. I think you learned it in your physics and chemistry. Okay, so this k is this thing. So we know that expression is dp dt equals to ln 2 over 10 times p. So that will be the expression. 5 marks. There we get it. 送分题, yeah. So now, second question. So the previous model what we had is that we have this dp dt. Yeah. They asked us to solve the thing in terms of p. So then we have this equation. P over P naught. Just now I did halfway. P over, you need to sub in T also, K also. K is become ln 2 over 10 times T. Correct? This is ln. Oh, the K is at the bottom. So this is something like that. So this is ln 2 10t. So this is 2 to the power of 10t ln p over p naught. So that means that the p is equals to p naught times 2 to the power of 10t. So let's keep on increasing now. When t go to infinity, p go to infinity. So this is not correct. So the new model, which looks more difficult, it said allowed the constraint for population growth, okay, which is normally happen. dp dt is equals to lambda p. Lambda is just now what we get. We use k, but I use lambda, is okay. And times 500 minus p. That means that is we populated, it will minus off the thing. So this is normal, the normal case. It's no longer a first order equation. Then they ask you solve these differential equations to find p in terms of t. So now we need to find the new lambda with a new initial condition. P naught equals to 50 while t equals to 0. P 10 seconds equals 100 while t equals to 10. So how do we solve this thing? Okay, when you look at these, don't panic. Because separation variable. Separation variable means that everyone is p at the left hand side, everyone is and t at the right hand side. Okay, so this is normally used in engineering. But when you do further math, I think the differential equation is quite different. Okay, so there will be a lot of techniques, which I'm not going to touch on this thing unless you go further math, because it's going to be taught in your first year engineering, school of engineering, or even you do electrical engineering. I mean, you're going to teach you how to solve the different type of differential equation. So obviously, we know that from this expression, it can be partial fraction. I'm a very lazy person. Normally, when I look at this thing, you see p and 500 minus p. Straight away, we know that the answer will be 500. 1 over p times plus 1 p 500 minus p, and this is dp. I'm not going to dilly-dally to do the partial fraction thing because I think it's wasting of time. Why? Very simple. I can cancel it off. So you need to do some mental calculations. On the denominator, on the top, 500 minus p plus p, 500, and then the bottom is p plus 1 over p, 500 plus minus p. I like to use bottom and top. You know why? So now we integrate both sides. 0, we know that is 50 lah. No need to tell, no need to say. But when I have t, okay, when I have t, it definitely gives me a p. So okay, normally if I want to do that, you can do it in that manner, but I rather put constant here because it look very messy. I need to do a lot of manipulation. So what I need to do is that I put 500 here, and then ln p, okay, plus or minus ln 500 minus p plus c equals to t lambda. So when t equals to 0, p equals to 50, right? So then c equals to what? So this is the where c we had to find out from here. So c when t equals 0, t lambda equals 0. Okay, nothing to say. So 500 ln 50 minus ln 450 plus c equals to 0. So c itself will become 1 over 500 ln 9. Okay, so this is c. 要心算hard calculation okay, so this is c, but we still haven't find the lambda yet don't be happy So now we have found c, then we found lambda. Lambda is when t equals to 10 it give me p equals to 100. Okay, so this is we're going to start everything 500 ln p over 500 minus p okay, we write properly first plus 500 ln 9 is equals to t times lambda. Got it? Okay, as simplified as possible. Don't make it complicated. When you do this equation, try not to use calculator because I think the whole objective here is not to teach you how to use calculator. Calculator is so easy to use when you go to engineering or financial course, I think you will know how to use it So this is the equation we are getting, but when t equals to 10, okay, p equals to 100, so we need to do this sum so lambda will be equals to 5000 ln 900 divided by 400, correct? So nothing to cancel this is 2 so become 2500 ln 3 over 2. Okay, so this is your lambda. So you can tell them that you can solve this differential equation, which is 2500 ln 3 over 2. Okay I mean a bit you need probably everything but a bit can't put this way, it's like a bit 麻烦 like that okay, just need to copy that then this 500, okay, even though a bit 麻烦, I think you can do it quite elegantly. This is 5, so you have this, everything is ln, right? When we in mathematics, when we look at such things we have a tendency that we try to make it nice 3 over 2 t over 5 is equals to 9p divided by 500 减 p. Okay, one thing I want to remind everyone, okay, that when you equal sign, write properly respect math okay, at the center so 9p divided by 100 minus p is equals to this. So further, I want the p expressed in terms of t okay, so what I need to do is that I need to apply whatever I learned in school previously. So 500 minus p 3 over 2 t over 5 to power 9p. So your p become try to in simple way of course 500 3 over 2 t over 5 to a powers divided by 9 plus 3 over 2 t over 5. Okay, see this t over 5 is quite when I do manipulation, I just want to make it simple, so I just make another minus t over 5 here plus 1. So this is my final answer for the p. So this is a bit kind of model that you've been exponential about it. So I think that is okay. So then they ask you that using the refined model, state the population of this species. This is question C already. Previous expression when t to infinity, this term is going to become 0. 500, right? Because t to infinity this become 0, right? 0 0 term okay? Anything minus becomes 0 because 3 over 2 is bigger than 1 correct? So you have anything that this 1 minus t over 5, and this will be very, very big. So this is 0. So it becomes 0. Then the population is 500. This is 2 marks only. Just now got 6 marks already. Using the refined models, state the population of this species in the long term. Comment that how this value suggests that the final model is improving on the first model. In the long term means that infinity Infinitas as it don't cheat by people say we put in a finite world. They're bullshit okay, because even the atom you subdivide it, you have infinitely many things. So this is towards to infinity. So when you look at, so you tell them that when t go to infinity, taking the limit t to infinity, for p is become 500. Okay, 550. That means the maximum population, or not maximum, the population will go towards 500. These suggest that the population in the long term will be kept at 500 rather than increasing with the growth, rather than increasing with the previous model spouted because when t go to infinity, p is bounded. Okay, so this explains the whole question 12. Okay, thank you.